line. So this equation 81 basically talks about the condition for a distortionless line. Okay, so when you put this particular condition, now when you are deriving the equation for distortionless line, what exactly you are going to derive? So for transmission line, these are the basic equations of the attenuation, which is represented by alpha, and the phase distortion, or you can say the phase constant along a transmission line. So because when you consider transmission, basically you are transmitting a signal from the transmitter end to a receiver end. So whenever a signal propagates from one point to other point, the signal will not be received as it is. Okay, because your line consists of R, L, G, and C, the signal will go through some attenuation also, and the signal will also go through some phase change. So that loss in the signal, which is represented by attenuation, and the change in the phase, okay, in the signal is represented by this beta. So alpha represents the attenuation constant, beta represents the phase constant. So these two equations are the basic equations, or you can say the generalized equations for alpha and beta. Now if you are deriving the condition for a distortionless line, as I mentioned, this is the condition, that is Lg should be equal to Rc. So you have to put this condition in these two equations and find out the value of alpha and beta. So first you take the equation for alpha, and in that you can put this condition, that is Lg should be equal to Rc, or L by C should be equal to R by G. And then by putting this particular condition, you can see here you get the equation for alpha, which is represented by equation 82, that is alpha will be equal to Rg. Similarly, if you put this condition in the equation for phase constant, that is beta, you will get the condition for beta for a distortionless line, which is omega root LC. So when you are deriving a condition for distortionless line, you have to define what exactly a distortionless line is, followed by the condition. You have to write down the condition. Then you cannot write directly this equation beta and alpha. You have to write the generalized equation for alpha and beta, and by substituting the condition in these two equations, you derive and you get these two values, that is beta is omega root LC and alpha is Rg. So that completes the derivation for distortionless line. You cannot write directly. ठीक है, आप करके देखो, कुछ ज्यादा इसमें बड़ा derivation है नहीं. You have to just put the condition in these two equation. Many of the things will get cancelled out and you will be left with only omega root LC for beta and root Rg for alpha. ठीक है. So that is the second part, distortionless line. Third part is the third part, which again talks about the second application, that is telephone cable. So when we say transmission line is to be used as a telephone cable, then for that, what exactly a telephone cable is? So here it is mentioned, that is wire which is insulated with paper and twisted in pairs is basically a telephone cable. Now when you do this, that is when you insulate that particular cable with paper, and when you twist those cables, because of that, what happens is your L and G becomes 0. So this is the condition for telephone line. So when you put this condition for telephone line, again in those two equations of alpha and beta, you will get equation 84, okay, which is for alpha and beta same only. आपको same equation मिलेगा दोनों के लिए भी. That is alpha is equal to again root of omega CR by 2, and beta is also root of omega CR by 2. So for telephone cable, what exactly it is, what is the condition, put that condition in the generalized expression of alpha and beta and write down the values for alpha and beta. Okay, so if you see here alpha equal to beta equal to omega CR by 2. So you just put L and G equal to 0 in that generalized expressions for alpha and beta, you will get this condition for telephone cable. Okay, so for transmission line, these are the only three derivations. Problems will not be there. The generalized solution of transmission line, then the special case, that is the distortionless line and the telephone cable. ठीक है, इसमें कुछ डाउट है किसी को या क्वेरी है या समझ में नहीं आया अभी भी? Anyone having any query? So this is for transmission line. Then I assume that you have those notes for unit number. I'll show you again. I hope my screen is visible. So this is the extracted PDF from the textbook whose author is Ravi Singh for unit number 5, two-port networks. So as I mentioned, these are the 6 parameters, but you'll be studying open circuit, that is Z parameter, short circuit Y parameter, transmission parameter, which is ABCD parameter, and hybrid parameters, that is H parameters. So for each of the parameter, as I mentioned, you have to derive the parameter. So this is the derivation, that is you define those two parameters in terms of, okay, dependent and independent variables. Okay, so these two are the governing equations. Then you derive those parameters. So derive means at one time you will be either open circuiting or short circuiting a port. So when you do that, you get first set of parameters, and then you apply the second case, that is either you open circuit or short circuit the other port. So you get the remaining set of parameters. So you will get these equations. Once you derive this, you have to also mention what exactly it is. Like here, if it is mentioned, you can see it is called as open circuit input impedance. Okay. Likewise, you have to derive these parameters. Then there is something called as equivalent circuit for the parameters. So this equivalent circuit is drawn. Okay. So that is first part of derivation. The second part is the condition for reciprocity and the condition for symmetry. So what exactly a reciprocity is there and what exactly a symmetry is there, that is already defined for each of the parameters. Okay. So they are pretty simple derivations, though it seems like 5 to 6 steps are there, but if you go through it, it's very easy actually. So you have to prove the reciprocity condition or symmetry condition for any of the parameters. Okay. So when I expect derivation, it's not like deriving the parameters, then drawing the equivalent circuit, then deriving the reciprocity condition, and then deriving the symmetry condition. Either of this will be there. Either you'll be deriving reciprocity condition along with Z parameters, or you'll be deriving Z parameters along with the symmetry condition. Okay. So likewise for Z parameters, then similarly you have Y parameters, that is short circuit parameters. You have equivalent circuit, then derivation, then transmission parameters. And the fourth is hybrid parameters. Okay. So these are the 4 topics, and there will be derivations, no examples on parameters. Okay. So I assume that you have this PDF, the extracted copy, or if not, I'll be sharing again if you want. Okay. Now for I activities, by tomorrow evening, you will receive your I activities. You have to solve them. Okay, and submit those activities in hard copy. Okay. So for each unit, I'll be submitting, or I'll be giving the activities. So there will be, you can expect at least 6 activities will be there for 6 units. So by tomorrow evening, you will receive those. Okay. And then you can submit it on Monday. So Monday, I think it is 2nd of September. Okay. तो कल शाम तक आपको मिल जाएगी आई एक्टिविटीज. Maybe either on the email I will submit or give you the activities. Complete it in a hard copy. Don't send me any PDF. Okay. So 6 activities in sequence, we complete them and submit the hard copies. Is that okay?
Yes, sir.
Yes.
So this is just because this week I am not available in campus. I'm outside or I'm attending one of the training sessions. So it is not possible for me to come. I'm coming in the evening, but again it becomes too late to have a on offline session in the campus. Otherwise, I'm ready for that also. But in the evening, it's not possible for some of them to wait in the campus. It's better that we'll meet on Saturday only for 2 hours, and we'll revise again quickly the exact contents what you have to study, from where you can practice again, and then we'll conclude the session on Saturday. So I expect, and in that session, if you have any doubts also, so we will discuss those things also. Is that okay? So by physically conducting on Saturday, I'll be completing or satisfying the Saturday criteria also. And if you have any doubts, or even in the evening also, if you are practicing, you let me know every evening, or tomorrow and day after tomorrow also, we can have online session only for doubts. But as far as teaching or few things which are remaining, that I'll be delivering in offline mode only. लेकिन कुछ doubt है तो every day we can have, tomorrow also we can have a session. You practice or discuss if you want to discuss any topic. You prepare it and let me know. So we can have a doubt solving session at least for 1 hour in the evening tomorrow also. ठीक है? So that's all from my side. You can prepare, or at least I have discussed for unit one, from where you can study the problems you can practice. So for unit one, as I mentioned, you can if you have the soft copy of Boylsted, okay, Robert Boylsted, you can have that soft copy, or the hard copy is there in the library also. In that you can practice the exercise problems only for AC circuits. तो उसका solution भी चाहिए तो मैं फिर से एक बार share करता हूँ of unsolved problems only for AC circuits. You can practice that examples. For theorems also you can refer the same book, and that is Robert Boylsted. For unit 2, you can refer, and I'll give the soft copy of that book also. For unit 2, you can prepare for the derivation of RL and RC circuit, source free as well as driven. तो यूनिट 2 में ये 4 डेरिवेशंस हो गए: सोर्स फ्री आरसी सर्किट, सोर्स फ्री आरएल सर्किट, ड्रिवन आरसी सर्किट, ड्रिवन आरएल सर्किट. ठीक है, दिस 4 डेरिवेशंस, and you can practice the problems on source free RL circuit, source free RC circuit. Okay. Unit 2, because I have not discussed the content for unit 2, because that was delivered by Ritu madam. So for unit 2, 4 derivations will be there. That is, you can prepare those derivations which are part of your syllabus: RL, RC, source free as well as driven. And problems you can practice for source free RC circuit and source free RL circuit. Okay. No problems on driven circuits. So that will be for second unit. Third unit I have discussed already. Only problems will be there for third unit: series resonance, parallel resonance. This you can prepare from again Robert Boylsted, chapter number 20. तो उसमें जो भी सॉल्व प्रॉब्लम्स दिए हुए या एक्सरसाइज दिया हुआ है उसका सॉल्यूशन आई विल शेयर. You practice those problems on finding the values of LC which we have solved in the classroom. Similar problems you can practice. Okay, for series as well as parallel resonance. For filter, already I have shared the PPTs. Derivation, you want me to derive again? It's already there derivation, or we have derived so many times. If you want, I'll derive that on Saturday. So it's hardly 10 minutes job to derive those equations. These are simple derivations. Saturday we can derive that. Because these sessions are basically for practicing the problems. Okay, because our course is not a theory course. If you have any theory course, then faculty will keep on discussing theory, sharing the PPTs. Here we require a lot of practice or discussing only problems how to be solved because it's more problem oriented. So you cannot expect that within 10 hours we can derive or start discussing each and every content or deriving each and everything. You can go through derivation. If you have any doubt, we can solve those doubts related to derivation. Now derivation will be there. Derivation will be there. Unit 2, there will be derivation. Unit 5 and Unit 6. And problems will be on Unit 1, Unit 3 and Unit 4. Unit 4, as I mentioned, constant ke high pass, low pass, M derived low pass, high pass. Okay. So already I have shared the PPT. In that PPT, there are examples also. नहीं है तो मैं share करता हूँ फिर से. Only for Unit 4, the PPT I have. I'll share that PDF file. उसमें जो problems है, you keep on changing the values of cutoff frequency, frequency of infinite attenuation and descent resistance and practice. Okay, whether you are getting the solution or not. Okay, so you just keep on changing the values and practice the examples because there is Unit 4, it's not too difficult. Standard formulas there. You have to just put the values and you'll get the answer. It's only a substitution problem. Don't have to think too much for solving the problems which are based on filters. Okay. So derivation, I'll go through that. I don't have any problem. Saturday will, in the first half, we can derive those derivations if required. Any other doubt? So you'll get your assignments by tomorrow evening, and then you can submit it by 2nd of September. I can see many of them, but during the actual offline lectures, 50% of them have only attended the session. So they are only eligible, okay? Those who have not attended any of my physical sessions or offline sessions, they are as good as detained. Derivation will be for unit number 2, unit number 5, and unit number 6. Only these 3 units have derivation. It's 2, 5, and 6. It's unit 2, unit 5, and unit 6. Okay. Is it okay? Any other doubt?
सर
Yes.
सर ऍक्च्युली मी ते प्रॉब्लेम्स प्रॅक्टिस केले ते तर तुम्हाला पाठवले होते ते आन्सर्स राईट ते स्टेप्स वगैरे ते राईट आहे का सर?
ते तुम्हाला जे वहीत दाखवले ते त्याचेच फोटो पाठवलेत ना?
हो सर.
का परत
मी
परत सॉल्व
सॅटर्डेला
केलते का
पण
ते?
दाखवत होते.
नाही नाही हा सॅटर्डेलाच की तू जाताना जे दाखवले होते तेच ना मला.
सर ते प्रिव्हियस इयर क्वेश्चन्स मधून सॉल्व्ह केलेले ते काही बुक्स मधले आणि काही पेपर मधले होते.
हा तर तू पहिले युनिटचे दाखवले होते ते तर चुकीचे होते. तुला सांगितलं मी की तू कॅपॅसिटर किंवा इंडक्टरचं कन्सिडर न करता डायरेक्ट इक्वेशन लिहिले होते. तर तू जिथं जिथं कॅपॅसिटर किंवा इंडक्टर आहे इन दॅट केस यू हॅव टू assume those resistance values to be imaginary. So for inductor it is plus J, for capacitor it is minus J, and then you have to write down those equations. तर तसं केलं नव्हतं तू. फिल्टरचं तू मला जे आज विचारलं कंडिशन that is correct. Okay, for filter. So that condition is correct. But there are many other sheets that you have shared. So if you require tomorrow again, only for you, if you have any doubt, we can have a half-an-hour session online. तर तू उद्या तयार ठेव काय काय तुझे अजून डाऊट आहेत किंवा जे सॉल्व्ह केलेत स्पेसिफिक. उद्या परत आपण पाहिजे तर 8 ते 8:30 घेऊ एक सेशन.
ठीक आहे.
फक्त अजून ते सोडून किंवा जे सॉल्व्ह केले ते नीट काय आहे, तू नुसते प्रॉब्लेम शेअर केलेत त्यात. चेक करायचं का कुठल्या स्टेपमध्ये अजून डाऊट आहे तुला, ते तसं तू आयडेंटिफाय करून ठेव.
ठीक आहे सर.
नक्की हां, तुला नक्की काय व्हेरिफाय करायचं किंवा कुठं अडचण आहे ते शोधून ठेव. मग मी अख्खा प्रॉब्लेम चेक करायचा तसं आहे, तर काय मला कळलंच नाही ते. तू नुसतं म्हणलं की चेक करा. चेक आता एवढे सगळे प्रॉब्लेम कुठे तुला नक्की काय ह्याच्यात अडचणी किंवा काय व्हेरिफाय करायचंय, ते शोधून ठेव तू सगळे प्रॉब्लेम जेवढे असतील तेवढे. देन यू शेअर
ठीक आहे
युअर
सर.
स्क्रीन एंड देन वी कॅन डिस्कस दॅट टुमॉरो अगेन. ठीक आहे?
ठीक आहे.
एनी अदर डाउट? Okay, then if you don't have any doubt, we can stop here. This was just only for discussing few things. And again in unit 6 also, the derivation which I have mentioned, you try that if you are facing any issues or if you're not getting those values, that also we'll discuss on Saturday also, or in tomorrow's doubt session. You come with your doubt, like in this derivation, after putting that condition also, you're not getting those equations. So that also we'll discuss. Okay, then we'll stop here. I'll share unit 4 PPT and the PDF copy of Boylsted along with the solution and the PDF for unit number 5 also. Okay, we'll stop here. Thank you.